In this proof, what we're going to deal with is a quadrilateral with sides A, B, C, and D. Since we're using vector method, we're going to call each of these points with reference to position vectors. So what do I mean by that? That the point A will have a position vector OA, and point B will have a position vector OB, and their directions will be from the origin. Okay, so you have these four vectors from the origin, which is OA, OB, OC, and OD, and these are called position vectors. So we'll be referring to these position vectors while we do this proof. All right. So the theorem here says a quadrilateral is a parallelogram if and only if its diagonals bisect each other. So we have to prove that this can be a quadrilateral. This quadrilateral can be a parallelogram if and only if the diagonals meet each other. So we will do this in two ways. First, we will show, or let's assume that it's a parallelogram, and we will prove that the diagonals bisect. And the second case we will take is that the diagonals bisect, and then from there we will try to prove that it's a parallelogram. Let's proceed. So let A, B, C, D be the vertices of the quadrilateral with diagonals AC and AD. So you have the diagonals here as AC and BD. Okay, and A, B, C, D are the position vectors of A, B, C, and D. So we're going to consider position vectors A, B, C, D with reference to A, B, C, and D. Alright, so with respect to 0 origin. Okay, now let the quadrilateral ABCD be a parallelogram. Like I said, we're going to first assume that ABCD is a parallelogram. So when we say it's a parallelogram, then the opposite side should be equal and they should be parallel. So which means vector AB should be equal to vector DC. So that's what we are assuming here. Since we are assuming this to be a parallelogram, so the opposite side should be equal. So AB vector is equal to DC vector. Now we can prove that the vector AB is equal to OB minus OA. How can we say that? Okay, now vector AB, if this is my, let me call this as my point of origin. This is my vector A and my vector B, which is OA. You can call it as OA and OB also. Okay. Now, this is my AB vector. Vector AB will be equal to vector AO plus vector OB. So vector AO plus vector OB will be equal to vector AB. And vector AO is nothing but minus OA plus OB, and that's equal to OB vector minus OA vector. So which is what we have here. And similarly for DC, we can prove that it is equal to OC minus OD, and replacing the values of the vector A, B, and CD into OA, OB, OC, and OD, we can get B minus A is equal to C minus D, and rearranging them, you can get B plus D is equal to A plus C. Now further, I can divide them by 2. You will get b plus d by 2 is equal to a plus c by 2. So what would that mean? B plus D would be B vector OB plus vector OD by 2, which will be the midpoint of BD. Okay, so if I'm going to draw a line, then that will be the midpoint of BD. And A plus C by 2 would be the point. If I draw a line from A to C, and that will be the midpoint here. So what does that mean? That the diagonals of A, B, C, D, they meet at the same point. Okay, so this proves that if this is a parallelogram, then using vector method, we have proved that the diagonals meet in the same point. Okay. Next, we are going to assume that conversely, let's assume that the diagonals bisect. So here we're going to consider that the diagonals bisect. So let's say the diagonals, let's draw the diagonals again. And let's say that the diagonals bisect. Okay, so if these diagonals bisect, we're going to prove that they are parallel. So we know that the diagonals, like for the diagonal of BD, the midpoint position vector would be defined as B plus D by 2, which we already saw here how to do this. And similarly for AC, the midpoint would be A plus C by 2. Okay, so that will be the midpoint. So since these midpoints would be equal to each other, we can prove, because they are, they bisect each other, that's what we have assumed, we can prove that C minus D is equal to B minus A. Just rearranging this formula, we get this. So what is C minus D? Vector C minus the vector C. Let's just write it down here. C minus D is OC vector minus OD vector. Okay, this will be equal to OC vector plus DO vector. So which is D, the origin is here, DO vector to OC vector is nothing but our DC vector, this vector here. So that's equal to DC vector. Okay. Similarly, we can prove that our vector B minus A will be equal to AB vector. So we see that AB vector and DC vector are equal. So since they're equal, we can say that the lines AB and DC are parallel. Further, we can prove that our A plus C is equal to B plus D by rearranging this. A minus D is equal to B minus C. So this means that our vector AD is parallel to vector BC. So here we can very clearly see that the opposite sides are parallel. Therefore, this is a parallelogram. So for both the condition, starting with the condition that it's a parallelogram, we proved that the diagonals bisect. And then conversely, we started by saying diagonals bisect, and we proved that it's a parallelogram by showing that the sides are the opposite sides are parallel. So that proves our theorem. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.